The topic today is types of chemical reaction. But before we continue, I'd like you to answer these questions. Pause the video and answer these questions. Pay very good attention. Pay very good attention. Don't rush it. Take your time. If you do that, this concept will be very, very easy for you to understand. But if you rush it without thinking about what you're doing, it will be a little confusing. Hopefully you got these answers. It says, which equation above has only one reactant? You know, we did reactants and products. So which one has only one reactant is number one. You see, there's only one reactant, okay? Then which equation above has only one product? Number three, you see that? Hopefully you got the same answer. Which equation above has oxygen as one of the reactants? Oxygen as one of the reactants, number five. Then which equation above has two ionic compounds? Or we can say two compounds is number four. You see that? Remember, ionic compounds is when you have a metal and non-metal transfer of electron from metal to non-metal. You see that? So one of the clues that tells you the ionic compound is there's metal on it. Okay. Number four. Which equation above has one compound and one element as reactants? You see, one compound and one element. Hopefully you got that right. Okay. Okay.
Reactions with classifying chemical reactions with the Flintstones. If Fred were to go to a dance and he were to meet Wilma, Fred and Wilma would combine together and form the Flintstones. This is called synthesis. When substance A is added to substance B and you get a combined compound of AB, you have created synthesis, similar to when hydrogen and oxygen bond together to form the molecule water, the synthesis of water. If, however, the Flintstones were together and they got a divorce so that Fred was on his own and Wilma were on her own, then you have decomposition. A compound breaks down into its component parts. AB yields A plus B. This happens in the decomposition of potassium chlorate, when KClO3 breaks down into KCl, potassium chloride, and oxygen gas. If, however, the Flintstones went to a dance and they met up with Betty, and when Betty showed up, she ended up with Fred, leaving Wilma by herself, we would call this single replacement. We are replacing one part of the pair. So AB plus C gives off AC plus B. We are replacing one part of the compound. This is called single replacement, and this happens when silver nitrate combines with copper to create copper nitrate and release silver. And our last type of chemical reaction is a double replacement. That's if the Flintstones went to that same dance, and there they met the Rubbles. And while they were dancing, Fred ended up with Betty, while Barney ended up with Wilma. In this case, we are exchanging two partners, this being double replacement. AB compound breaks down along with CD compound, which breaks down compounds AD plus CB. An example of this would be a double replacement reaction where potassium nitrate combines with magnesium chloride, and ends up being magnesium nitrate plus potassium chloride. This is classification of chemical reactions, and thank you to the Flintstones.
The video, which is cartoon, really introduces you to types of chemical reaction. And I'll use, that was a very good analogy, and I hope you really followed it. So let's look at each of these types of chemical reaction. One is synthesis reaction. It's one in which two or more reactants combine to make one type of product. Very easy. Let's say you see that? You have two reactants, you end up with one. As long as you have one product, that's synthesis. You have one product, okay? So looking at it here, there's so many different ways that I try to represent it. You see this? You ended up with one product. So that's synthesis or combination reaction. You can call it combination. Try not to memorize this. Try to use the name to make sense of it. Synthesis, combination, they combine. But if you are trying to do it without thinking about the vocabulary, it'll be difficult. Then decomposition reaction, when one type of reactant breaks down to form two or more products. You see that? You have only one reactant, you end up with two or more products. That's decomposition reaction. You see that? You start with one reactant, you see that? Then you end up with two or more products. Then before we continue with another type, which is single replacement, let's look at this chart. Look at this chart. Activity series chart. Some people call it reactivity chart. Okay, it has metals in order of reactivity. You see metals, that means the one on top is the most reactive. This one is least, okay? Then it has to have non-metals. In order of reactivity, fluorine being the most reactive, iodine the least reactive. These are the halogens, okay? Halogens. Now, what does this tell us? This is used only when we want to talk about single replacement. If you watch that video closely, when it talked about single replacement, you saw that you have a couple, you have another one that by itself, and that one kick one of the couples out and takes its place. It can only kick the other person out because it's more active. Okay, so if let's say this is the one that is by itself, the element by itself, and the one with another non-metal is this zinc will kick this calcium out and takes its place. But if this one is by itself, it cannot kick the zinc out. You will not understand it. Let me use an equation, okay? This is, but the only thing I want you to know from this activity series is that the metals is in order of reactivity. The one on top is in decreases. The activity decreases as you go down, but increases as you go up. The same with this, increases as you go up, decreases as you go down. That's one major thing I want you to get from this. Then let me give let's go to the single replacement. So this is in single replacement reactions. One element reacts with one compound to form products. Okay, the singular element is said to replace an element in the compound. Look at it. You have this is by itself. You see, this we take the place of this and kick this out. If this is not high in activity series, it cannot do that. Okay, for that to happen, this one has to be high in activity series. You see, it took the place of B and kicked the B out. So The element replaces cation of the compound. So you see that? Then this is exact example also of that. Now, there are 3 different types of single replacements. Then I have a little one so that we can be looking at it directly. When you have the element kick, this one, it says single replacement when is metal involved. So this is element, this is metal, this is metal. This kicks this out and takes its place. Look at potassium is right here. It has more strength than sodium. That's why it can do that. Okay. Now, when you have metal with acid, this is acid, this is metal with acid. Then this zinc, which is here, kicks out hydrogen. So hydrogen is somewhere, it's not showing here, but some hydrogen is below the zinc. That's why zinc can kick hydrogen out and takes its place. You see that? Okay. Then we have the one that is when is non-metals involved. You see the order here, non-metals involved. Chlorine is by itself. This chlorine will kick bromine out. Chlorine is more reactive than bromine. It kicks bromine out and takes its place. Okay? Chlorine kicks bromine and takes its place. So these are the 3 different types of single replacement. Then more examples of single replacement. This one is I want you to practice kind of or to see what is going on. You see potassium kicks magnesium out. Magnesium below it has more is more reactive than magnesium. But what I would like you to do is to also balance this equation. I want you to balance it. Then you see aluminum and iron. Aluminum is right here. Iron is right here. This is Latin name, okay? Iron is right here. Aluminum kicks iron out, okay? Let's look at copper. Copper is right here. Can it kick magnesium out? No, so there's no reaction. Sometimes when you do experiment and there's no reaction is because of this. The copper is not as reactive as magnesium, therefore, it cannot kick magnesium out. So no reaction will take place. And then you have mercury, it cannot kick zinc out. Also no reaction. So no reaction here, no reaction here. We can't have a product if there's no reactant. So you try to balance these 2 equations. This one, you can't because there's no product, no reaction happened. Then double replacement. For double replacement reactions, 2 reactants will react, which are compounds, and will exchange places, trade places, like you saw in that video. Look at this. Okay, we have AB and SY. This will be 2 compounds, sometimes ionic compounds. Okay, you see how A, this used to be A, now is X. This A and X, which are cations, they trade places because during the reaction, the ionic compounds will break apart and then we trade places to give this product. So this is a better way of looking at it. You see this? A and C. Now C is with this and A is with this. Okay, look at it very well. Then this Another example of that, you see this silver and sodium, they trade places, okay? Then there's combustion reaction. Example of that is burning. And we know for combustion to take place, there has to be oxygen. Okay, it has to be a compound and oxygen, like you pour fuel with oxygen, it will burn. So this happens when you have hydrocarbon. Hydrocarbon is when you have a compound that contains only carbon and hydrogen. Then with oxygen, but one thing with this type of reaction, it always produces carbon dioxide and water. The heat is given off, okay? And then fuel is another example with this carbon dioxide and water is also given off. And then this carbon tetrahydride, we call this common name is methane with oxygen, carbon dioxide and water, okay? You see that? You see this? You must be familiar with equations now. The product is always carbon dioxide and water. And the reactant is, we have oxygen. Oxygen supports combustion, okay? And we see that here, hydrocarbon plus oxygen, it gives carbon dioxide and water. That's when we have this, that's why, combustion reaction. Sometimes we also have incomplete combustion when the combustion is not, we don't have enough oxygen for the combustion to take place. We call it incomplete combustion. So I hope you understand that. So let's look at this simulation. Get your pen and pencil ready because there'll be quiz at the end. You can take notes. So this will help you much visual understanding of what this animation actually, what is going on. Pause the video. Let's look at the summary. Synthesis, 2 or more reactants make one product. Decomposition, 1 type of reactant makes 2 or more products. Single replacement, 1 element species react with 1 compound to form products. Double replacement, 2 compounds act as reactants. Combustion, a fair reactant reacts with oxygen gas. Okay, so that's the summary of everything. So you relate this to the first question you answered in the beginning of this video. So there are no answers for this question. Pause the video and answer this. But what I do before you do, I will give you example, maybe 2 examples on how to do this, okay? So that you will understand it. This example will be similar to the practice question you'll be answering. So how do you figure out the answer to this one? There are several things. You will predict the product and write the type of reaction. When you have elements, from what we just, you have elements and a compound. Obviously, this type is single replacement. You should know that. Remember, it can be replacement or displacement, okay? Some textbooks use replacement, some use displacement. They mean exactly the same thing. Okay, now, this one involves like with acid, element, metal and acid, right? So this zinc will kick hydrogen out. You look at the activity series, you see that zinc is higher than hydrogen. So when it kicks hydrogen out, it will take the place of hydrogen. It will be zinc chloride. Okay, now you have to refer to what we did on writing formula. How do we write formula between zinc and chlorine? You have to do that. Then hydrogen is kicked out, and hydrogen cannot exist as this. It has to be this. So now you're applying everything we've been learning. So how do you write the formula for this? The cation for zinc is transition metal, but it can only form 1 type of cation. And anion chloride is like that. These charges are not equal. So you do crisscross. So this will be, your product will be this, okay, plus hydrogen. So to make it neater, it will be this, zinc chloride plus hydrogen. This is diatomic element, those elements that comes in 2s. I hope you watched the other videos before this, because all of this we explained. Now, is this balanced? You will balance the equation. Let's say this is zinc. If you choose to draw, I use drawing because many students, for some reason, they didn't do, they don't know this already. So then they've not been exposed to this. So I try to remember this is not the accurate structure of the element. Now, so how do you make this equal? How do you make them equal? Each kind of atom equal on both sides. So now, to balance this, there's 2 chloride here, there's 1 here. So I add another set of this. So this will be 2 sets here, and then 1 zinc here, 1 zinc here, 2 chloride, 2 chlorine, then 2 hydrogen, 2 hydrogen. So this is balance. This is non-balanced equation. It's single replacement. It is balanced. Now, this one, you have magnesium and chlorine. when you have two elements like this, you will form one compound. Okay, there's magnesium, there's chlorine. Okay, you have to do this. This is the cation of this is this. You still have to go this way. You can't say, oh, MG, though for this one, if you do that, it will come out, but that's not correct. That's not correct. Okay, so you will end up with this. Okay, so it will be magnesium plus this. This is synthesis or combination reaction. Okay, so the reason I decided to show you this is, let's say in the lab, we are doing experiments. You know what is a reaction between zinc and hydrochloric acid. You're supposed to be able to write the equation. And if you know the type of reaction, you can predict the products. It's very, very important. Okay, it's very, very important. So here's a practice question. I do not have any answer for this. I expect you to really think through what you are doing and get it right, okay? So I hope this is clear. Thank you for watching.